This recorded presentation is a brief demonstration of the basic elements of a Sigmafine model and how the user interacts with some of these elements. The presentation is recorded by Roberto Linares, PIMSoft Vice President and Sales Executive for the Americas.
I will start this demo by showing a Sigmafine model within ProcessBook. As you can see, there are different element types: tanks, meters, streams, nodes, process units, receipts, shipment points, and also, in some cases, transfers or movement between different elements. To access the properties of these elements, you can click on AF Properties, and for example, for this meter, you can see the attributes that this element contains, the values, the data references, or the way that the values are evaluated, and also the unit of measure of each particular value. As you can see, different elements have different properties and different calculations. In this case, for example, a tank has a gauge, a volume, a net volume, a density, and other properties. A unit, for example, might have less properties because that's simply, from the point of view of reconciliation, a mass balance or volume balance point. And as we go across, we can see a complete network, which is balanced at the same time when we are performing data reconciliation. If we would like to see how these calculations are configured, we can look into, for example, a data reference. And here we can see that we are performing a mass to volume calculation using the units of measure data reference. And if we keep clicking the dialog, we can see how this data reference is configured. In this case, we're calculating mass from volume using density. In this case, I'm just going to go ahead and cancel. In other cases, we can have the Sigmafine data reference or other data references. For example, here I'm going to see the configuration of a volume correction factor. A volume correction factor is used to transform the computation of a gross volume to a net volume using the properties of the material, the temperature, the density, and we can even apply an old standard or the new standard of the API 2004. So I'm going to go ahead and cancel out. So the first task of the model is to generate information, input information for the model. We have a connectivity model that has all of the inputs and outputs that will be used in the solution of the data reconciliation model. And the way that the system is configured is here, where you configure the analysis properties. In this case, we're performing a Sigmafine mass balance. We configure what are the inputs for inventory, streams, transfers, and elements, and all the rest of the elements, and the quantity outputs. What will be the reconciled information that each attribute will contain? For example, measurements on streams and balances. Balances will have an imbalance and reconciled test 3, while meters will have a test 1, and the reconciled mass will be written in the stream that the meter is connected to. Once that is configured, the analysis rule is ready to be used. We can also configure the frequency of the analysis rule. For example, here we are configuring that the rule will be executed every day from Monday to Sunday through Sunday with an offset of 5 a.m. So we just simply say OK, and then we can cancel. So once the system is configured, the steps that are taken by the users are as follows. The user creates a new case, and simply collect transfers in the case there are some transfers in the system, we can collect the inputs. Here we collected 848 inputs. Some of them are calculations, others might be data references, uh, getting data from Pi, for example, and others could be relationships within attributes. Once the data is there, now we have around 848 inputs plus any other fixed inputs. So the system is ready to run. I can simply say run. So now I'm executing the reconciliation process. In this case, the network is a linear network that is getting the reconciled information for every element in the system. For example, in this case, we can see the correction, what is the reconciled mass of the tank, what is the observability, or what we call solvability. In this case, it's redundant. And we can go ahead and look at the different elements to see what is the reconciled information. And we can even compare reconciled information versus measured information for a particular item. So as you see, we have a group of cases. So once we have run the system, we can also publish the information. We can say published, and we can publish back the information either to historian, or we can publish the information to SQL to generate reports using the SQL Sigmafine SQL Access. So then it is possible also to look at the information using a different tool within ProcessBook. This is called the Advanced Diagnostic add-in. This add-in is very powerful because it allows us to see information globally for the model. We don't need to browse each particular element. We can look at all of the elements at once as a data set. In this case, we are looking at the tanks. We can sort by names. We can look at the status, gauge, the closing amount of liquid, the mass amount, the reconciled inventory, and the statistical imbalance test 3. Now, all of these attributes can be configured according to the needs of the user. So we can also go and look for meters. In this case, we can look at the meter information. What is the name, the object status, its object status, the measured mass, the reconciled mass, and also the statistical test. In this case, we are looking at this value, which is red, that shows that there is a big correction for this particular element. So we can click and we can look what meter is causing this problem. This is M underscore ALK underscore C3. We can also go to the different nodes, and then we can see that there are some issues in this node NC4, and there is a big imbalance compared to the other nodes. And then we can go and look at the processes, sort by initial imbalance, and in this case we see that the DHT process unit is having a large imbalance. And then we can go ahead and look at tank information and sort also by the values of statistical values generated by the reconciliation process. So this is the way that the user can see information at once, and even it can go and find the location of a particular item in the diagram for any of these elements. Of course, it's possible to create more tabs according to the user needs.
Thank you for listening to another example of innovative solutions by PIMSoft. To learn more about elements, models, and how to use them in Sigmafine, attend our training class called Using Sigmafine.